Okay, 5.1, modeling a quadratic function. So before we begin, let's just review what a quadratic function looks like. So f of x is equal to ax squared plus bx plus c. Remember that this is your quadratic term, so we're going to label that quadratic term. And we know that's the quadratic term because it has an x squared in it. So this is what makes it a quadratic, the fact that it has an x squared term. So if you remember back to the last couple of chapters we talked about, we were just dealing with linear terms. So just to review and make some connections here, the linear term or the linear equations were of x is to the first power. Linear, first power, makes it a straight line. Quadratic, x to the second power, makes it look like this. So now it looks like what's called a parabola. So x squared is a quadratic, x to the first power was linear, and since this x is to the first power, we call this our linear term. Okay, and the reason is x to the first power. And then the very last term is called the constant term. And we call it the constant term because all it is a constant, which means a positive or negative number. It is x to the 0 power, and if you think way back to Algebra 1, anything raised to the 0 power is equal to 1. So if I had 2x to the 0 power, I have 2 times 1, which is 2. So essentially, there are no x's. You have just the number, just a constant. So we call that the constant term. And the last thing I want to tell you about a quadratic function in this form is that this is what we call standard form. Okay, standard form. We will be working with quadratics in vertex form as well later, but right now just standard form. Okay, so classifying functions, there's two steps in classifying functions. The first is to simplify. So we will simplify, and what does that mean? Simplifying means that we're going to multiply. Maybe we're going to distribute. Maybe we're going to FOIL. Maybe we're going to collect like terms. But those are all simplifying. So we're going to take these and multiply them out. We're going to distribute, we're going to simplify, collect like terms, and we're going to get it all the way down to its most simplified form. Then we are going to decide if it is quadratic or not. And we just talked a second ago about the fact that if it has an x squared term, it's a quadratic. So x squared term, then we're going to say, yes, it's a quadratic. If there's no x squared term, then we're going to say, no, it is not quadratic. Okay? So we're going to use these two examples. Part of your homework is going to be to multiply these examples out, classifying them, and then also to label what you have left for terms. Okay? So looking at example 1, we're going to distribute 2x times x, and that is 2x squared. And then we are going to do 2x times negative 4, that's negative 8x. And then 3 times x, and then 3 times negative 4. And I'm going to combine my like terms. Negative 8 plus 3, negative 5x minus 12, and that is as simplified as it gets. And since there is an x squared term, I'm going to say yes, that it is quadratic. And to label my parts, I'm going to say this is the quadratic term, negative 5x is the linear term, and negative 12x is the constant term. So you're going to be labeling them after as well. Okay, example 2, distribute the 3. So f of x equals 3x squared minus 6x. And now I'm distributing negative 3, so negative 3x squared. And negative 3 times negative 2 is positive 6. combine like terms. If you look carefully, you see that the like terms, positive 3x and negative 3x, cancel. And we are left with f of x equals negative 6x plus 6. And that is as simplified as that gets. And since there is no quadratic term, we're going to say no, this is, not a quadratic. And then I'm going to label my terms. So this is a linear term, and this is a constant term. So there is no quadratic term in this example. Okay, so we're going to scroll the page. So I'm going to just move my page down so we can work on the next section. I'm going to clear it, and we're going to start fresh with reading quadratics from a graph. So parabola. So the first thing we're going to do is just talk about what a parabola is. It is the graph of a quadratic. The graph of a quadratic. The axis of symmetry, which I oftentimes abbreviate to AOS, is a line that divides a parabola into two congruent halves. Okay, a line that divides the parabola into two congruent halves. This is an important word because the equation of the axis of symmetry is always a line. Okay, and if this is the equation of the axis of symmetry, the line that divides the parabola into two equal pieces, that is the equation x equals 2. Okay, so a line, and it's always going to be x equals some number. Always, always. So be very careful about that, okay? The vertex is the point. So given as an ordered pair, a point where the parabola intersects the line of symmetry. Okay, so the vertex in this particular example is found right here. That is the ordered pair 2, 0, and it is our vertex. Okay, so we have the axis of symmetry, we have the vertex. The last thing we're going to talk about on the graphs are the maximum and minimum, maximum being the highest point, and the minimum being the lowest point. And so these points are found and equal to the y value of the vertex. Now, we'll talk about that a little bit as we start graphing them in the next section, why it's the y value of the vertex. But basically, here's your vertex, and that is the lowest point on the graph. And so what is the y coordinate? Y coordinates give us the distance up and down, the position up and down of our graph, and this is the lowest y value, and it happens to be at 0. So the y coordinate is 0, and that is also its minimum value. So the highest point is when the graph is heading downward, and we have the maximum here at x, and then whatever the maximum point is would be your y value. And the minimum is when the graph goes this way, and we would have the point x, and then whatever the y value is would be the minimum. Okay, so your max is found and your min is found equal to whatever the y value of your vertex is. Okay, and so in this case we would say has a minimum that is equal to 0. All right, one more very quick thing and we will be done the lesson. So we're going to scroll the page up. we're going to identify parts of graphs, parts of parabolas. So this part will be easy, I think. So we are first going to identify the vertex here. We're going to identify the axis of symmetry. And then we're going to identify the points that correspond, there's a word from geometry, to P and Q, corresponding. So let's first start with the vertex, which would be right here, and that is the point over 1 and down 1. So 1, -1 is where I find the vertex. Okay, the axis of symmetry would be found right here. So what is the equation of the axis of symmetry? It's over at 1, x equals 1. So that's how we write it, x equals 1. And then I want the point that corresponds to P. So here's P, and I want the point that corresponds to it. So what they mean by that is, here's a line of symmetry. You learned in geometry that if you have a point that is 2 units away from the line of symmetry to the left, it has a corresponding reflection 2 units to the right. And so this would be P prime. And so we're asking for P prime. And remember, we call those little tick marks in geometry prime, meaning that we've taken the original point and now we've shifted it, transformed it some way, and this is its new location. So the new location of P and its reflection would be over 1, 2, 3, and up 1, 2, 3. Remember, you always count from your origin. Over 3, up 3. We're going to do the same thing with Q, so we're going to reflect it over the line of symmetry to this point, which happens to be 0, 0. Okay, last example. Here's your vertex. Backward 1, up 2. So -1, +2. The axis of symmetry is going to be found right here at x equals -1. I'm going to reflect P 1 unit to the right over the line of symmetry. So P prime is at 0, 1. And Q is 2 units to the right of my line of symmetry, so I'm going to reflect it 2 units to the left of my line of symmetry, and that from my origin is back 3 and down 2. So back 3, down 2. Okay? And so that kind of takes care of this lesson in a nutshell. You can certainly ask questions when you come to class. You might want to get started on your homework.